I always like to say in this field with social skills, it's like in the land of the blind, the one-eyed man is king. We as engineers are very smart and very intelligent, and who are we kidding? We're not the most socially savvy people in the world. Hey there, welcome to Book Overflow. This is the podcast for software engineers by software engineers dedicated to reading the best technical books in the world in an effort to improve our craft. I am Carter Morgan, and I'm joined here by my co-host, Nathan Toops.
Hey, everybody.
Well, it's good to be here. Forgive us, I am in a hotel right now. I am in Toronto for a company meeting. My voice might be a little hoarse from some of the activities we've done, and we are learning as we go as we record this episode, so bear with us. But if you are tuning in or if you follow the podcast, you know that we typically read a book a week on this podcast and discuss them. The book a week is somewhat of a marketing term. Really, we read 200 pages a week, and we break the larger books up into multiple weeks. That is what we have done this week. This is part 2 of our series on Fundamentals of Software Architecture by Neil Ford and Mark Richards. We read the first half last week, and this is the last half. And I think we both really enjoyed it. What do you say, Nathan?
Yeah, this is a great book. I definitely throw this on the top of my recommendations list.
Yes, I feel the same way. I think we felt the same way after the first half, and even feel even more that way after the second half. We'll give a quick summary of the book and then the authors of the book. Well, I guess let's start with the authors. This is the author introduction as listed on the book. First, Neil Ford is Director of Software Architecture and Mean Wrangler at ThoughtWorks, a software company and a community of passionate, purpose-led individuals who think disruptively to deliver technology to address the toughest challenges, all while seeking to revolutionize the IT industry and create positive social change. And Mark Richards is an experienced, hands-on software architect involved in the architecture, design, and implementation of microservices architectures, service-oriented architectures, and distributed systems in a variety of technologies. And we'll read you the Amazon blurb again, just to keep you up to date. The blurb for this book, straight from Amazon.com, says, salary surveys worldwide regularly place software architect in the top 10 best jobs, yet no real guide exists to help developers become architects, until now. This book provides the first comprehensive overview of software architecture's many aspects. Aspiring and existing architects alike will examine architectural characteristics, architectural patterns, component determination, diagramming and presenting architecture, evolutionary architecture, and many other topics. So that gets us up to speed. Nathan, what did you think of the second half of Fundamentals of Software Architecture?
Yeah, so we're part 1 really laid the foundation for a lot of the stuff we were doing. Part 2 and 3, which are the rest of the book, they really dove into a lot of the tactical information that you would need, how the actual architectures work, how you would approach them, what the trade-offs are, which is like a big theme in the book. And then that final piece, which goes into, I guess, more of the soft skills. I really loved that section. I think it's hard to pick a favorite, but if I had to, and what I'll probably go back and reference more in the future is going to be that section 3. I'm sure we'll get into it.
Section 3 is great. Yes, big focus on soft skills there. I had a lot of the same thought. I'll save my thoughts for that section. I love this book because it gives you an overview of all of the different kind of architecture patterns that you have probably seen throughout your career, and maybe could even construct a semblance of if tasked with reconstructing them. But it's like putting a name to a face, and it gives you an overview of not just the different architectures, but why they exist and why you might choose a specific one and the pros and cons with each one. We talked about this a lot last week, but the core conceit of this book is the idea that everything in software engineering is a trade-off, and that especially applies in building software architectures. So this book isn't here as it goes through the architecture patterns to say, this is the best architecture, you should do it this way. It says, here are a lot of different choices, and here are the pros and cons of each choice. What you need to do depends totally on your situation.
Yep.
And this book is divided into 3 parts. We did part 1 last week, and we're doing parts 2 and 3 this week. Parts 2 and 3, part 2 is that architecture overview, and then part 3 is kind of like a career skills section, which Nathan alluded to. That whole part 3 is fantastic, and we're excited to talk about it. Go ahead.
I know I did want to mention one thing that is I really enjoyed the pacing of this book. It's a longer book, and so the pacing is crucial. And I felt it was a nice balance. We talked about this when we read the philosophy of software design. It was wonderful philosophy book, but very short. And then there's
Mhm.
the refactoring book, which kind of got, I think, too much into the weeds. It felt sometimes, though. I think if I needed it as a reference book, this book somehow balanced the two. I feel like it was just enough detail on implementation, but also let us stay with philosophy. And so, um, the authors being able to pull that off is really impressive. I'll just say,
I agree 100%. This was a refreshing read after the previous episode, which was what is ChatGPT doing and why does it work? Which is not a knock on that book. I love that book, and it's actually been great as I've been at this big company summit this week. There's been an AI focus, and it's been really great to speak knowledgeably and somewhat authoritatively. Obviously, I'm not an expert by any means about the subject, but also put in a plug for the podcast. You would be shocked that if you spend 1 week reading a book on a subject matter, how much that makes you the subject matter expert on that subject at your companies. Put in the effort. But anyhow, reading that book, fantastic book, very dense, and
yeah,
I had to read and reread parts of it to understand it. Didn't have to do that with this book, which is not to say it's a breeze, but it felt informative and light at somehow the same time. And that could just be because of the subject matter we're coming from. Nathan and I we're cloud architects to a degree, and so maybe this would be harder if you didn't have that kind of experience. Either way, I totally agree on the pacing. I thought it was a delightful read.
yeah. If there's like a data scientist out there who reads this book, maybe they'll have the similar experiences we did at GPT book.
Yeah, absolutely. Well, why don't we get right into the architectural styles? They list several different architectural styles. Like we say on this podcast, this is not a book report, but a book club. So we do not aim to give an authoritative, exhaustive review of the book. Rather, we just pick some of the best ideas and talk about them. Let's start with some of the foundations and fallacies they lay out. Nathan, I think there was a particular architectural anti-pattern they laid out, which I
Oh
enjoyed, but I
man,
think you particularly enjoyed. Why don't you take us off
yeah.
with there?
I've worked in a bunch of early stage startups. I've also just been in existing code bases, and I think anybody who has been in a code base will this will resonate with them. They start off talking about big ball of mud, which is just such a good way of describing. And I think a few months ago I was talking to one of our folks, and he mentioned big ball of mud, and I thought it was just like a clever thing he had said. And didn't realize that this was actually referencing like a paper from 1997. And, in this paper, they actually mentioned, they say, a big ball of mud is a haphazardly structured, sprawling, sloppy, duct tape and bale wire spaghetti code jungle. These systems show unmistakable signs of unregulated growth and repeated expedient repair. Information is shared promiscuously among distant elements of the system, often to the point where nearly all the important information becomes global or duplicated. And I felt the pain. I've been there. I think the sooner you identify a big ball of mud or that you're moving that direction, it's a really good sign that you need to, correct course or figure out how much tech debt you actually have to mitigate. But I'd love to hear your thoughts on the big ball of mud.
I have experience with the big ball of mud before. It's funny as they were talking about big ball of mud, and there was another particular architecture which I can't remember which one it was, but I have in my show notes as I'm recording my Kindle. I
I think
broke
I
out in
know.
cold sweats
Yeah.
reading about this because
I'm
just
guessing
hearing
it's
about.
the orchestration driven service oriented architecture, if I
I
had to
think that's
guess.
exactly what it
Yeah.
was. Some of my show notes didn't sync since I read most of this book on the airplane. Yes, reading about that and the big ball of mud. I've been there. I think we have all been there. I think there are probably plenty of our listeners who listen to that description of the big ball of mud and think that has a name. I thought that was just software engineering. So, like I said, that's one of the things I love about this book is it kind of puts a name to a lot of those concepts you've dealt with before. I've been fortunate that at some of my recent companies that I've worked at some major companies, and I don't see this as much, but I definitely saw it at a lot of the smaller companies. And why do you think that is, Nathan? As someone who's been at smaller companies more,
Well, I think that architecture in many cases is an afterthought. I think that's part of it. I
I
think
would
that
agree.
there's the tech debt of trade-offs. So a lot of times we would joke at some of the early stage startups I was in that we launched a rocket, but we actually don't know where it's going. And we're like fixing the rocket and aiming it to the right place as we go. And that's not the best way to build a rocket, right? Like you really want to have a plan before the rocket goes out. Except in an early stage startup, you don't necessarily know what that is. You don't even maybe know what the correct customer is, what your product market fit is. And so because there's business decisions and architectural decisions, or maybe a lack of architectural decisions, maybe you have a, you know, plucky straight out of college software engineer who's just kind of been thrown into making architectural decisions and doesn't even know that's a thing that they need to be doing. Um, you end up getting a big ball of mud more times than not, I think is you know, what kind of comes out of that.
I would agree. I think at larger companies, when you're about to start a big new initiative, one, you don't tend to have them written by plucky software engineers right out of college. They tend to be more established engineers, maybe engineers who have read this book, and you have the time usually to architect something correctly. But I don't think that there is speed does not necessarily mean that you cannot architect. That's something I believe in somewhat strongly, that there's not nearly as much a trade-off between good code and fast code as we'd like to believe. It's not any harder, or it doesn't take any longer to write good code. You
Yeah.
just have to be in the habit of it. In the same way, it's not any faster to build a big ball of mud than to build any of these other architectures they talk about. I guess it could be marginally faster. It's just not as purposeful. And so
Right.
I think that's one of the great things you could get from reading this book is if you're tasked with building an architecture at a startup or you're just starting out, the first thing I would do is I would just, if I'd read this book, I would come back to it and I would just flip through section 2 and look at all the different architecture patterns. And then I would at least have like a North Star of what I'm aiming for. Like I'm trying to
Yeah.
do like a service-based architecture or microservices or microkernel. And we'll talk about some of those in just a sec. And even though it might wind up being a bit more of a big ball of mud than you'd like it to be, I bet just having that framework and that goal of what you're getting towards will result in a cleaner architecture, even if you're building fast.
Yeah, I think the other one, and we'll learn about this, with one of the architecture patterns. And we've talked about this in other episodes. Encapsulating complexity, right? We don't want complexity in a system if we can avoid it, right? Simplicity is better. Simple is better than complex. Complex is better than complicated. That's like from the Zen of Python. And if you have domain specific code, you can encapsulate, even if you're like one team has a ball of mud in one of their microservices, that's way better than the whole system being a ball of mud, right?
Absolutely.
And if you're not careful, that's very simple. And that's what, again, they talk about that, like this global variables and all this coordination that's to happen. And as you scale up, it just becomes, cripplingly difficult to get over the tech debt for that. This is a good segue into some of the fallacies. So they talk about
Yes, let's talk about
fallacies.
those.
Yeah, so the fallacies that architects run into, but I think these are universal, and I think every software engineer would. I know that they really resonated with me. We don't have to, again, not book report style. We don't have to get into every little detail. So some of them we'll breeze over. If we feel like we want to elaborate, we will. But they outline these problems and patterns, and I loved this section. First one they start with is the network is reliable, and this is this sort of assumption that you're writing all your business logic, and let's say you're using, especially for distributed systems or interacting with third-party APIs. These are two areas that things can happen. It's easy for developers and architects to alike to assume that the network is reliable, but it's not, right? And so we're dealing with this actually with some third-party integrations on a project I'm working on, where I said this in our meeting. I said we're too optimistic that this service is going to operate as we expect it, and we need resiliency built into our code. And they talk about these sort of things of you should build the software so that you can mitigate and deal with the fact that the network is unreliable. Things go wrong.
I
These,
felt so
yeah,
called out because it's a list of fallacies, and this is probably along with the definition of a fallacy, but for me, it's a list of things we take for granted.
yes,
And it's a fallacy in the sense that, like, we assume this will always be true, but it's not. Designing a software architecture is already so hard. I think we forget that about our jobs as software engineers, that the base level of knowledge you need to even operate and be anything approaching competent in this field is already incredibly high. Technical people have the tendency to consistently overestimate the technical knowledge of non-technical people, and we take
right,
our technical knowledge for granted. So you're already operating at a fairly high level just to be able to open an IDE, write some Python, and run it. And then you have to be operating at an even higher level to build any sort of comprehensive software architecture. And I think
right.
we get to that level and think, well, I'm operating at such a high level that there can't be anything more than this, right? Even knowing how to build this is insane. But we need to operate at an even higher level, which is we need to look at some of these assumptions that they list out in this the list of fallacies and realize we can't always hold these to be true. And just like you said, Nathan, we assume the network is going to be reliable because it's already dang hard to build a system that connects to each other. Why would I
Right.
think that the connecting part isn't going to work? I don't know if it's wishful thinking. I don't know if it's delusion. I don't know if it's uh, not doing our due diligence. But I think I run into this all the time. You assume the network will be reliable. You don't plan around it. You can't make that assumption.
And and this is where things kind of cool. The fallacies kind of blend into each other in some ways because it's a similar idea that, this, I think part of this is that, oh, it worked on my machine, right? Like when you're in local dev, you're dealing with simulated network connections and maybe like a local Kubernetes cluster on your machine or something. And of course, you're not having to deal with any of the real network congestion or these other pieces. The other part was, and this was interesting, it gets into these other areas, which is the third party that we were dealing with used to be more reliable. We actually have the data now to show that they've been struggling. And so the fact is that it used to be reliable and things change. And this gets into some of the other fallacies. So latency is zero, right? So this is related to the idea that network was reliable, which is that it's not a zero amount of time. That we're dealing with physics. An electron has to be, there's a causal limit. They call it the speed of light.
Yeah.
The longer things are apart, whether you're switching from NCPU cache to RAM on the machine to disk to network calls, right? All of these latencies have a cost to them. And this is something that we have to think about. Then this also ties into bandwidth is infinite. So again, on your local machine, you might have, especially if you're like on an M1 processor or something, the bandwidth is crazy, right? Very, very good to get data from one place to the other. As soon as you push this over a network, um, especially if you're in a microservice with a bunch of other services contending for network bandwidth, you might actually hit real limits of, if you're on a gigabit network, everybody assumes they get a fifth of that. And then you add 20 services. Well, if you're all doing high bandwidth streaming, you're going to hit a limit. I also loved this one. The network is secure. This one, I wear a security tinfoil hat a lot as sort of background. And there's a couple things that came up. Number one is, a lot of companies will pick, oh, we have a VPN solution, or the real fancy stuff that we're doing now is called Zero Trust, where you do some like cool managed reverse proxy things. But you have to think about the security between services. Just because you have this walled garden around your app, and it made me think of the fact that, like, years ago when the Snowden leaks happened, this was a bullet point in slides in the NSA disclosure documents where they were like, hey, we just got a connection into the Google data centers. They don't encrypt their traffic internally. So we would just pull the data out. And of course, the
Wow.
huge revelation to the big tech companies, Facebook and Google, started doing what they call MTLS, or mutual TLS between services. And within a couple of years, this became standard and best practices. And it made me think about this idea that even these big companies, they're like, oh, okay, well, we encrypt everything between data centers. But if you got inside of a data center, most of the traffic was not encrypted. And a lot of startups are
I
still
think
like that.
Well, and we're going through this, and there's still a few more fallacies. Again, I'm struck by we take all of this for granted. We
Exactly.
assume the network will be secure. You talked about that idea that works on my machine. I remember being at my first job right out of college, and I was trying to share some sort of application I had written, and they were going to get it up and running on their machine, and it didn't work. And I completely innocently said, I don't know what the problem is. It works on my machine. And everyone in the office like clapped and cheered. They're like, hey, because it was my first time coming into that. And I just thought that was totally normal. I'm like, what do you mean it doesn't work on your machine? It works on my machine.
Right.
But it's not enough. Same with all these fallacies we're talking about. You can have an architecture that works perfectly in a simulated environment or in a best case scenario, but it might be because you are taking some of these fallacies for granted. And we can go on and talk about some of the other ones too.
Yeah. So topology never changes. This one's really interesting. So topology is the structure of the system that's built. And one of these, this one was a little bit more abstract, but I think if you get into the meat of it, it's really cool, which is that external changes happen. And especially if you're in a distributed system, distributed team, your software and your architecture needs to be resilient to the fact that the world will change around you. Whether you like it or not, this could be an emergency patch to a logging framework, which is what happened a few years ago. This could be that some network administrator did an upgrade on how the network functions, and all of a sudden you're getting rate limited when you weren't getting rate limited before, and these kind of things. This also ties into the next one, which is there's only one administrator. And I think this is one I've been affected by, where you kind of model in your mind and you're like, okay, well, this privileged access, they're the only ones that are going to do this one special thing. And especially when you start growing, or if you're in a large organization, that's just not true. There's admins everywhere. They will not always be able to communicate or coordinate, and they're going to make decisions. And so your system needs to be built in a way defensively to say, and this, I think, where a lot of things like zero trust and low trust systems have come from, which is that, hey, somebody might change the security architecture, or they might actually be able to like do a schema migration on a database. How do we build an architecture so that if they change this, it doesn't affect us, right? The last two are kind of interesting. Transport cost is zero. And I think this one is something that I've seen time and time again. Transport cost is zero is not talking about the opportunity cost. It's actually talking about a lot of times you'll build these beautiful systems, and then you get your cloud bill and you realize you didn't optimize for the fact that egress is super expensive. And all of a sudden you just blew your whole budget out of the water because your app gets popular, you're streaming a bunch of stuff, and all of a sudden, because you didn't negotiate rates or you're not using a CDN properly, what you built costs way different than how you set expectations with leadership.
This is something I'm terrible at, because I just wrapped up a couple years working at a cloud provider, and we got a 99% discount on internal products. And so we just built anything and everything because it was essentially free to run on the cloud. And now I'm at a company where we obviously don't get that. And it's been a readjustment, a change in my frame of mind. Like, okay, we actually have to consider our cloud costs, and these are not small costs.
No, we actually, we're big enough now. We have about 300 ICs at our company, and we're large enough now that we actually have a dedicated FinOps team, and this is this financial operations, and literally the leadership in that goes around and tries to figure out, like, are we cost optimized in how we're doing, and he's looking for patterns constantly. And it's a whole discipline now. It's that actually, there's a FinOps book. We should read that one in the future. That's kind of cool.
Throw it on the backlog.
The last one is network is homogeneous. This is one that will bite you too, which is, okay, maybe your service or your section has some high performance network or has some predictable network. The idea is that the network can be heterogeneous, right? It's going to be, maybe some services are network constrained and others have huge pipes. And you need to, again, this gets back into the defensive side of things, is you understand that things change over time. And this is something I've done a lot. Actually, it's my little bag of tricks. If I like swoop into a new company, I will immediately review instance types that we're running. What's the network bandwidth that's available? Because a lot of times when I'll see bottlenecks, it's because there's either CPU, disk IO, or network constraints that they hadn't analyzed. And especially if I see network saturation is one of them, I try to make the network more homogeneous if I can, right? It's making sure the expectations are there, but rarely is that the case. And yeah, this is I'd love to hear your thoughts on this as well.
Yeah, I agree. I wish I were more well versed in the nitty gritty of some of these details. Like I say, I've spent my time mostly at larger companies, which is neat because you work at a scale that you don't get at some smaller companies. It's not as neat because some of these details get abstracted away from you. So that, and I think that's why, like I said, I felt called out in this section of the book, because with these details abstracted away, you just don't think about them. So this was a great reminder for me that these fallacies exist. They are major components when designing an architecture. And just, we talked about this last week with the book, this idea of increasing your technical breadth. I'm such a big fan of it because after reading this list of fallacies, am I an expert in every single one of these potential haphazards? No, absolutely not. But I'm aware of them now. And when I go out to design a software architecture, one of the things I'm going to do is pick up this book and consult this list of fallacies and say, okay, am I assuming that latency is zero? I am. Okay, so let's address that. Am I thinking about that monetary cost? Am I thinking about if the network is secure, or am I assuming the network will never change? And when you have that kind of checklist, and they talk about checklists later in the book, I think, again, you don't need to be an expert in everything, but just knowing what you don't know and knowing even the general idea of the pitfalls you might fall into is a really powerful concept.
Yeah.
Well, I think this is a great time to talk about the different kinds of architectures they lay out in the book. We will be back with that and more right after a quick break. And we are back. Thank you so much for tuning in. Well, like we said, part 2 of this book lists a lot of the common architectures you might find or might consider when designing a software architecture. We are not going to give an exhaustive list of all of these different architectures. There's some we won't cover, like layered and pipeline and microkernel and things like that. Rather, we're just going to talk about some of the ones we found the most interesting, both for positive reasons and negative reasons. And I think we're going to start off the bat with the architecture that made me break out into a cold sweat, the orchestration-driven, service-oriented architecture. Nathan, let's talk about this one.
To quote from the book, architecture styles, like art movements, must be understood in the context of the era in which they evolved. And the architecture exemplifies this rule more than any other. The contribution of external forces that often influence architecture decisions, combined with a logical but ultimately disastrous organizational philosophy, doomed this architecture to irrelevance. However, it provides a great example of how a particular organizational idea can make logical sense, yet hinder most important parts of the development process. And it's beautiful because you have to be really careful. We're going to talk about microservices or service-oriented architecture, and this is not what those are. This is something that is meant to serve the Conway's Law piece here, which is that you're going to ultimately build the way that your organization is structured. This is building software to serve an organization structure, an enterprise software organization structure that gives you the worst of both worlds. And they argue that this is a distributed system with a monolithic deploy model, which is that you're now taking the most complicated topology and then using the least valuable for large teams way of deploying this. And so instead of having domain-driven patterns, you now have to coordinate across this chaos in this universe of things. And if you can hear it in my voice, it's already starting to sound like a big ball of mud. And this is what really comes out of it. I think a lot of us have seen these really complex deploy systems, they're typically broken out by like business service, enterprise service bus, enterprise services, application services, and infrastructure services. Like everything's built around these domains, and then have a bunch of pieces that are in it. But you can't update the system unless everything's coordinated with each other, right? Application services probably have some dependency on updates to the enterprise service bus. And if the enterprise service bus isn't updated with the right version, then the business service and the infrastructure services can't function properly. And so you spend a ton of time coordinating and negotiating. And as you can imagine, the tech debt gets super complicated. The coupling across services gets really complex, and you have to do a tremendous amount of orchestration coordination. So the orchestrator, which is what does all the deployments and updates, has to be very, very aware how each piece of the system works. And of course,
as an example,
it's a disaster.
Yeah, as an example from the book, it talks about these enterprise services, right? It says the enterprise services contain fine-grained shared implementations. Typically, a team of developers is tasked with building atomic behavior around particular business domains, create customer, calculate quote, and so on. These services are the building blocks that make up the coarse-grained business services tied together via the orchestration engine. So you can imagine, I think we've all worked at companies that have like bespoke tooling, or you can't just look up online, like, how do I deploy using Terraform? You got to figure out like the Terraform wrapper that your company wrote. This is like
Right.
that on crack. And if you want to create a customer, you can't just, like a microservices pattern, we're going to talk about microservices. You can say, okay, I know the customer data model. I'll just write my own customer class. We'll get it from the database as we need to. Here, you would think, like, I can't just create a customer. I have to figure out what service creates the customer. How do I call it? How does it work? What is it returning?
Right.
And calculate quote. They talk about how this went out of style, but they basically they give some of the justifications for why this architecture evolved. They said many external drivers forced architects in this era toward distributed architectures with significant constraints. Before open source operating systems were thought reliable enough for serious work, operating systems were expensive and licensed per machine. Similarly, commercial database servers came with Byzantine licensing schemes, which caused application server vendors, which offer database connection pooling, to battle with database vendors. Thus, architects were expected to reuse as much as possible. In fact, reuse in all forms became the dominant philosophy in this architecture. The side effects, and they talk about with reuse and coupling. And I can totally see why you would do this. If licenses are expensive and computing power is expensive, why would you have each team create their own create customer service? If you've already built that at one point, just reuse it. Like, that's still a pattern we hold to today, that idea of dry code, don't repeat yourself. Mm-hmm. This is, in a way, dry architecture. But the problem is, it's like you said, Nathan, you get monolithic deployment with a distributed system. So you have everyone working on their individual parts, but they all have to reuse these common systems. And then that means that the power brokers in charge of the common systems become these huge political figures and have a ton of power over how everyone works. And that means that if one of those systems get updated, cascades ripple out through every other part. Like I said, I was breaking out in a cold sweat thinking about working with this architecture.
Yep.
I understand why this came to be, and I'm not knocking we stand on the shoulders of the giants before us, but holy cow, I'm glad we've evolved as an industry.
And you also see a lot of the scar tissue from this. And, lots of organizations still deploy code like this. Unfortunately, I think the symptoms are these big monolithic release cycles. So you'll say every 2 weeks, we stop everything. QA does some crazy acceptance testing. It's probably very manual. And then they sign off on it. And then you trigger the deploy and you hold your breath and you hope that everything in production was set up the same way that it was in staging, right before it, or whatever UAT, like user acceptance testing environment. And of course, it's inherently dysfunctional. Can you do successful deploys? Yes, of course you can. But the teams that deal with these deploy failures and have to do these crazy rollbacks and do these really complex things are the ones who do the deployments less frequently, or who have built on this assumption that the system all must work together perfectly. And so, yeah, I think that's a good segue into a couple of other architectures that are really interesting. I think we'll save the uh, microservices for last, which I think is a wonderful answer to this architecture. But before that, I think there's one that really spoke to you, Carter. And I think we
Absolutely.
should.
I just want to make one last comment about it, this last architecture, which I think one of the dangerous things about it is that it seems sophisticated. Like a big ball of mud, you can't even design an architecture pattern around it. Like it's just like, nah, it's a big old mess. This is like a big ball of mud wearing a top hat, because you can understand there's business reasons behind this. And if you could draw up an architecture diagram for this, and it would look like there'd be justifications for what you're doing, but you're not thinking about the larger why. And so I think you could build this thing and say, hey, we have rules, we have guidelines, we have a pattern and a strategy for why everything should work. And that's better than just building crap for the sake of building crap. But it, like we talked about, it results in a lot of hard processes, strict coupling, hard deployments. Yeah, oof. I'm glad I don't work with this anymore. And I'm glad I've been able to work with some of these other architectures. One of the ones, like you said, that really spoke to me, I liked the event-driven architecture. I think this is such a neat, extensible form of architecture. If you're not familiar with event architecture, the basic idea behind it is that you break out all of the processing you do into different events that usually wind up in queues. And then you have different systems that are working through the queues, processing the events that come along. You can imagine like a food delivery system, for example, where the order gets placed for the restaurant, and then your order placement service dispatches that event to the order preparation service at the restaurant. It goes into a queue, and then in this case, it would actually be physical restaurant workers working through the queue, but it waits its turn in there until the restaurant worker makes the food, and then it dispatches the order ready event, and then the order tracking service picks up on that. What I think is really cool about this architecture is how extensible it is. They actually talk about this idea that you can broadcast events that never get consumed. So let's say, for example, at the end of this restaurant delivery architecture I'm describing, there is the order received event. And maybe there's no system that subscribes to the order received event. Maybe once the order is received, we actually don't care what happens and there's nothing to do, but you can still broadcast it. And that means that later on, if we want to actually do something with the order after it's been received, that event is already being broadcast into the ether, and you can just pick up on it and start working with it. And so I loved kind of the extensible nature of this architecture. They talk about two different ways you can implement it. They have a broker topology and a mediator topology. The broker topology is what I'm talking about. This idea that you can kind of send everything out into the ether and then build services around all of those different events that you might be outputting. They say it is always a good practice within the broker topology for each event processor to advertise what it did to the rest of the system, regardless of whether or not any other event processor cares about what action this is. And they say it's a good example of architectural extensibility. While it may seem like a waste of resources sending messages that are ignored, it is not. Suppose a new requirement comes to analyze emails that have been sent to customers. This new event processor can be added to the overall system with minimal effort because the email information is available via the email topic to the new analyzer without having to add any additional infrastructure or apply any changes to other event processors. So again, the extensibility of this really spoke to me. They talk kind of on the other hand, the other side of the coin. Instead of a broker topology, you could have a mediator topology. Here's how they describe it. They say, like in the broker topology, the initiating event is the event that starts the whole eventing process. Unlike the broker topology, the initiating event is sent to an initiating event queue, which is accepted by the event mediator. The event mediator only knows the steps involved in processing the event and therefore generates corresponding processing events that are sent to dedicated event channels, usually queues, in a point-to-point messaging fashion. Event processors then listen to dedicated event channels, process the event, and usually respond back to the mediator that they have completed their work. Unlike the broker topology, event processors within the mediator topology do not advertise what they did to the rest of the system. So there's kind of two ways of viewing this, right? Broker topology, you send your events out into, like I said, the ether, and then you can build systems around that. They're not necessarily explicitly talking to each other, but they can, it's like a relay race, right? One system finishes its work, broadcasts its event. The next system picks up where that one left off, and so on and so on. The mediator topology is the opposite. That you actually have sort of a central coordinator, and it's still sending out its events in an event-driven fashion. It sends it to this system and that system, which have a queue, and they work through it, but then they report back to the mediator. So in that case, you're not so much broadcasting to the rest of the world, and anyone can pick up where you left off, but you are working in a very distributed, asynchronous fashion. It all comes back to the mediator, and then the mediator can basically give the ultimate sign off on when something is actually done.
Yeah, I loved this, and I like both of them. I have a couple of examples of where I've used this in the real world. The broker topology was huge for us, and I was an early stage startup. We actually were very focused on architecture, and we had a monolith. It was fine for us, so it was easy for us to reason about the system. But we knew we wanted to start introducing some microservices, and one of the things that we were able to do is implement this event-driven sort of broker topology. We started broadcasting preemptively on events that we knew other disconnected parts of the system would be interested in. We updated some table in a database, or we added a user to our system, or a guest was, on a trip, or, we would just start broadcasting these events out to the ether. And you can kind of think of this as like chat rooms. So let's say you're in Slack and you are, you're at your office and you wanted to post in the random channel, or maybe you want to say something in the DevOps channel, or maybe there's like a water cooler channel, right? These are the sort of topics that you might say, let a group of people who might be interested. And your message doesn't have to have a response, but somebody might be like, oh yeah, I'm going to go like read this thing, go do something, and then, phone home to the same topic that I did something else with it, right? And you can kind of think of this as this sort of broker topology. It's decentralized. The mediator topology, it reminds me a lot of, I've used with success is Amazon has a tool called step functions, which
I love step functions.
Yeah, and so step functions are these state machines, right? And so it's a distributed state machine, and that's this mediator topology, which is that there's something that's keeping track of all of these disconnected asynchronous things that have to happen, but it's sort of keeping the state machine of the pipeline function. Do I fan out? There's all these logic and stuff that can happen. It's just one example. You don't have to use a step function to use the mediator topology, but it's very successful, especially when you have, let's say, one of the famous things with step functions is that you can do a bunch of automated processes and then have a human sign off on some step. And then it picks up where it left off and keeps going. And none of the other parts of the system have to have any awareness of the human sign-off step, right? Like these all still have the isolated, domain-driven, architecture.
They're just waiting for the event that says, okay, human sign-off step complete, but it doesn't matter that it's a human that's actually triggering that event. It functions the same as every other part of the architecture. It's just waiting for it.
And it's very composable with some of the other systems, like pipelines, especially distributed pipelines. A lot of times, like I've used a tool a lot called Airflow, and Airflow is a way of modeling data and these things called DAGs, or directed acyclic graphs. Well, you describe the relationship between everything, and then Airflow is the moderator who says, okay, if this happens here, then signal this other place. But none of the steps, you don't asynchronously talk across the steps, right? It's really the mediator who's like mediating all of these processes and making sure that the steps take place. And so these have been, yeah.
They did say with this architecture that one of the hard things about it is error handling, because you are you're distributed across all of these different asynchronous workflows. So one, figuring out why an error happened can be hard because you might have to trace it across all the different systems. If you're building something like this, you're already probably very into like a cloud environment. You're using cloud computing to do this. I guess you could build this on-prem. That sounds like a nightmare, but I guess you could. So if you're going to do something like this, make sure your whatever logging tool you use out of the different cloud providers, like make sure you've got all your logs coming to a centralized place and it's easy to query them because you're going to be looking at logs across lots of different systems. They also say that this can be hard, that if an event gets broken somewhere along the way, right, you get kind of 3 systems down in the baton relay race, and then that system can't handle it. Like it can't kick it back to the previous systems necessarily. They gave an example where sometimes when you might have a completely separate like error handler service, and then anytime an error happens in any of these systems, you kick it to the error handler service. They gave the example of like placing a stock trade, and you might place a stock trade and then realize that, like, for example, if you want to buy 500 shares of Apple, the data model should just be Apple and the number 500. But the user might have accidentally submitted 500 shares. So you have that shares text as well. So that will give that might make it a few chains down in the relay system before it picks up and says, wait a minute, this input is wrong. So you kick it to the error handling service. That can be comprehensive and take a look and see what's wrong. And in that case, it might say, we just have shares in here when we shouldn't. It cleans the input, and then it actually sends the event back to the very beginning of the whole process where it goes along. And then they also gave an example. I thought this was neat, that there might be some errors that require human input. So you could have the error, kick it to the error handling service, but then that might decide, oh, wait, I need a human to take a look at this. So you kick it to like the human queue. And then a human has an actual dashboard they can log into, which has a list of all of the different errors and then, or the suspect transactions. They could review each one. And then if they say, okay, I cleaned up the data, or this looks good to me, they just click submit. And then what does it do? It sends it back to the beginning with that initiating event. So again, I love the extensibility of this, but we can't forget about the error handling and the lack of simplicity that comes with this. It's a complicated system.
Something like a database transaction. You can flag that, let's say you need to update 3 tables in a database, but you want it to be a single transaction, meaning if any step in this fails, I can roll back to the previous state right before it happened. In some cases, you do need to have a multi-step distributed asynchronous transaction, but they tell you that you should largely avoid this if at all possible, right? That can you build this in a way that's idempotent, that is more declarative about where we are in the state, versus like if you have something that must touch 5 steps in your procedure and then something fails and then you have to unwrap that, it can be pretty difficult to reason about, right? It's pretty difficult, especially if you're doing the broker topology, where you may not even know what other systems cared about this, right? It might be sending out a message, some other analytics service is keeping track of the number of successful customers, and it doesn't know how to unwrap the fact that the credit card processing failed, and so therefore you actually have to like unwind that the shopping cart was emptied. This is not trivial, and again, there's a lot of great advice on how to think about this in the book.
Yeah, and I think that it goes to the whole concept of this book, which is that everything is a trade-off. There's no one true architecture. Like I said, I found this architecture fascinating. At one of the companies I worked at, and like I said, it's just great to put a name to a face, because reading it, I'm like, oh, we were a mediator. We were an event-driven architecture with a mediator topology. And it was just cool to recognize that after reading this. But it's just a bunch of trade-offs. And we're going to talk about the trade-offs that come with microservices, because I think if there's anything in our industry which we have deemed the one true architecture, it's microservices. But like everything, it's just a trade-off. We'll be back with microservices and more right after the break. And we are back. The final architecture we're going to talk about, out of all the architectures they reviewed, is the microservices architecture. Now, if you're listening to this podcast, I'm going to guess you're a fairly tech savvy person. You'll know that microservices have become very popular in recent years, and they devote a good chunk of the book to discussing them. Nathan, you were particularly interested in this subject. Why don't you talk to us about what you thought?
Yeah, so I've been doing microservices work since probably 2016 or 2017, and things have shifted a lot. And I think this is what you'll see here, especially with what we just talked about with event-oriented architecture and the cautionary tale of dealing with the orchestration-driven service-oriented architecture, is that microservices is a way to deal with these large-scale distributed systems, but in a way that's actually maintainable and sustainable. I will say there is a bit of, we talked about cargo culting before. There's a bit of cargo culting, and some people just think that if they build a microservices architecture, they'll get to Google scale, which is not true. I think there's some jokes that people have said, which is that microservices are for people who hate each other, kind of a thing. Like it's this idea that, but really, microservices is an organizational structural decision. It's not a way to build high performance applications by itself. They're a very huge monolith, and if that's how your team works well together, it's great. Actually, DHH and folks who work over at 37 Signals, or I guess they're Basecamp now, they're a big contrarian group that really advocates for the monolith, and it really works well for their team. What the purpose of microservices is to give a bounded context that each service models a domain or a workflow in the business. And what that means is any part of the microservice architecture can be updated independently without coordination with everyone else. So your team who's working on some domain of the business can operate in a way that you control the database behind it. The database is not shared with other services. You control the modules and the dependencies that are inside of this service. And some people, they talk about this. Some people take this overboard. Microservices doesn't mean that some tiny little piece of business logic lives by itself, and that everything has to be like broken down into these like super tiny modules. They even argue about this. If you're having to do a lot of coordination across microservices, they might need to be combined into one service. You might have artificially broken a domain that shouldn't be there. They talk about this in the sense that, like, if you're the user auth service and you're constantly dealing with like user analytics, and the two services have to coordinate with each other in some weird coupled way, you might just want to make this a broader user service that deals with analytics and the user auth and these other things together if need be. Again, it's all trade-offs. But the idea here is that this is an architecture that cultivates a single purpose nature topology, which means that your domain and your service doesn't need to coordinate with everybody else, that you have an evolutionary architecture. And they talk about this idea that like the business can evolve over time and figure out what it's doing, and you can renegotiate where these boundaries and domains are. That you get this clean data isolation. So, I get to control the database that is all the state and the scalability of my service, and how retry logic works, and these other pieces. But you also, they have a huge section here on, maybe I want to have a synchronous call. Maybe I do need a synchronous call, let's say with our auth service, to see, do I have access to this other part of our system? And maybe that I have to block on that and wait for the answer and come back. But a lot of times, most of the services, you're going to want this sort of event-driven architecture as well, right? You would imagine for things like an analytics service that is maybe gathering up all the events, so like click-throughs and all these other things. You probably just want to broadcast that, right? You just send it out to a channel. I did this thing. I did this thing. I did this thing. And the analytics service is listening, and it's going to go and asynchronously handle, recording that this thing happened and putting it in some, big data warehouse or whatever. And what's cool about this is that the teams are left up to this themselves. Like, your domain gets to decide, okay, here's all the asynchronous event pub sub stuff that I'm doing, and here's how I'm going to store things in the database, and here's how I'll let everybody else know about, how the service is structured.
What I love I love that you bring up the team dynamic, and they talk about this later in the book. They say, "I forgive me because I don't remember the author, but the quote is, no matter what they tell you, it's a people problem." Architecture, this architecture really embraces that idea of building what do they say? They say the primary goal of microservices is high decoupling, physically modeling the logical notion of bounded context. And you give a lot more control to the individual teams. And so, the as compared to like a big ball of mud or like what was it called? The event driven orchestration service based architecture. I don't even remember. Even the name terrifies me. You don't have to have this high coupling across all of the teams. Each team can control their system independently. Microservices to me really embody that idea of abstraction. I love the idea of abstraction in computer science. I always give the example of like, I know nothing about cars, and the whole process of how a car works is abstracted from me. I know I turn the wheel to make it go left and right. I know I press the gas pedal to make it go forward. But if tomorrow night someone came into my garage and replaced all of the internals of the car with a completely new system, I would still get up the next day and drive the car, and it would still drive exactly like I did. That's what I love about microservices, because if a team is, I don't know why you would make this decision, right? But let's say you've been working in Node.js, and as your service begins to scale, you realize, we got to go to something a little zippier. We're going to rewrite the service in Rust, right? So long as you don't change the API contracts, how you're exposing it to other services, you could completely gut your system and replace it with an entirely different implementation, and it still works. And I think giving teams that individual freedom over how they work their product is a really powerful concept.
Yep. And that comes into some of the complexities too. So very important concepts is that we always called it our social contract, which is the API that you expose. You never break the API. That was like step one, right? So let's say you have some new fancy version of the user, endpoint. You're going to need to V2 that, right, on your API documentation and add some new required fields, and then encourage the rest of the teams to move to the V2 version of the user API. But you still have to support the V1 user API. If it's an internal API, you can be more aggressive about deprecation and like coordination. If it's a public API, you're probably going to have V1 of the user API indefinitely. And then add more and more features to V2 so that no one wants to use the old version, because the V2 version gives you all the cool new stuff. But they talk about, there's some really important concepts. Again, distributed logging becomes really important. If services depend on each other, this is where like a whole industry called, there's a framework called OpenTelemetry, and it gives you a way of like annotating your logs and traces and metrics so that you can coordinate across them. And if you pass them in the right way, you can actually have like a trace ID that could flow through the system. Really kind of cool concepts, but you have to kind of wrap your head around it. Service discovery. So this is the idea that like microservices really rely on the fact that microservices can figure out where the other ones are, even though you may not know where they physically are. So there's typically some sort of DNS or naming conventions. This gets back to naming connaissance, which we've talked about early. Is that service discovery is built on this entire thing? Like all I need to know is that there's a pricing service. I don't know where it is, but I asked the service discovery thing, and it kind of helps me understand where it is.
You can imagine the headache of needing to remember the individual IP addresses when you're making queries.
Oh, yeah.
Something awful like that. Yeah, service discovery. That's a concept that I find fascinating. Again, it's one of those things that's been abstracted away from me too much in my career. And reading through this book, I was like, I gotta dig into the nitty gritty of how service discovery works. Because like you said, it's a huge component.
Yeah. It used to be so difficult. It's really, really cool now. And then again, it gives us a lot of like, so I'll say one of the things that are the cons, right? Is it's complex. So there's no way around it. You have to have what you would consider like a DevOps team or site reliability engineering team that really understands the orchestration piece. And it's kind of funny, while you do give lots of independence to these domains, you typically have settled on a pattern for doing things like creating an artifact, deploying that artifact into the cluster. And those things are coordinated. So there's like a monolithic design to how orchestration works. right? That's that. How do I interact with Kubernetes? And yet there's a very decentralized way of allowing the teams to have autonomy within that sort of orchestration piece. The other one is it's not the cheapest way of modeling a system. And so I think those are
I
the
mean,
two.
that's why it's come to be in recent years because computing has gotten cheaper. But a lot of the original architectures they talk about are just a function of cost, and they exist
Right.
to bring costs down. We really do live in a great age where computing power is relatively cheap. So you can wind up with microservices, but there is taking it too far, right? I have heard horror stories of companies that had more services than developers because you just break
Yep.
everything out into its smallest possible processing unit. I also thought an interesting idea was the almost like the microservices anti-pattern. They talk about architectural quanta, right? Which is a quantum in architecture is you define a quantum by does all of this stuff have to be deployed together? Is this an individually deployable artifact? And so if you can have like almost a microservices anti-pattern where you have like 10 individual services, but they all talk to the same database. And so if that database changes its data structuring, you affect those 10 different services. And you have to do deployments across those 10. This company I worked at, this fun little startup, was like that, where we had all of these different like microservices, but there was one database. And so it winds up being an architectural quantum of one.
Right. Well, and this gets into the fallacy. So there's a one administrator fallacy. This is violated, right? Because as soon as somebody makes a database design decision that affects the other teams, you're together. In the pure sense, this is not data isolation. And so therefore, even if you called it microservices, it's not really if you're using the same database. You can call this a service-oriented architecture where you're thinking about this. And I've seen this happen many times, and I've been in that boat too. Early on, we didn't understand the separation, or it felt expensive. Like, why am I doing this like really simple Postgres database that maybe has like 2 tables in it when I could have a cool Postgres cluster and then everything like talks to it? Or honestly, in the Wild West days, it was MongoDB because nobody wanted to think about schema, and so they would just like have a huge MongoDB database and then think
I'm
about
guilty of that. I'm like, what?
well,
Schema? No. Just throw a JSON object in there.
Blob stores, joins and how expensive those are. But yeah, it's having to coordinate your 10 microservices and making sure that doing the deploy doesn't break it because we didn't do DB testing or something. You're starting on that path of the big ball of mud, where all of a sudden you're going to wake up one day and go, oh my gosh, we're doing monolithic deploys on our microservices because we got burned 2 weeks ago when we had a Sev 0, right? And so that's a good time to say, well, maybe we can't break up the whole database, but my team, we're going to spin up a database and not be part of the big database cluster, right? It's where the evolutionary architecture can happen and how you can introduce things like microservices. And I've seen this happen where a team goes, you know what? We're going to make replicas of our tables, pull them out of this shared database, run our own thing. And then other teams can fall into line. And then eventually you'll have data isolation like you should with microservices.
But like they say, everything is a trade-off. And so you might find yourself on the opposite end of the spectrum where you'll say, listen, we have our giant database and we like it. We think that's the right call for this, or this reason, but we have 10 microservices interacting with it. And so we're having to coordinate these 10 different deployments every time we make a change to the database. Maybe we should consolidate. Maybe we should be moving to more of a monolithic structure. Like I kind of said earlier, if there's anything that's been christened as the one true architecture in the industry, it is microservices. And I like microservices. I think I've always been more interested in the intersection of people and technology than the technology itself. And not just even from a user perspective, but from the teams that build the technology. So I'm really partial to microservices because, like I said, it gives teams high control over how they build their system. And I think it increases velocity. But it's not always going to be the right pattern for your problem. Only you can understand your problem. And they talk about, as an architect, a huge part of being a software architect is understanding the business domain around the problem space. And if you understand that business domain, that's going to help you understand how you might want to structure your data and your architecture. And then once you understand how you want to structure your architecture, you can decide what architectural pattern you're going to have. And is it going to be microservices, event driven, pipeline, microkernel, any of the different architectures they talk about in the book?
So this is a really great segue. Let's say you have the cool architecture design, or you're trying to convince the business that you need to make some change. Part 3 is about techniques and soft skills.
This is my favorite part of the book. We will be back with it and more right after this break. And we are back. We just wrapped up our discussion on part 2 of the book, which goes through all the different software architectures. But part 3 of the book, we found equally, if not more fascinating, and it is techniques and soft skills. Because like Nathan said before the break, you have to know how to sell your idea. You have to know how to work with others. And this whole last section of the book is about just exactly how do you do that. Nathan, there was so many great concepts in this book. We could dedicate multiple episodes to this section alone.
It's true.
Why don't you start? What's something you liked from this section and that you'd like to talk about?
Yeah, I've made every mistake in the book. So I the job before this, I was actually chief cloud architect at a early stage startup. And man, I wish I had read this book before. Yes, especially the first section here is architecture decisions. And there's 3 big anti-patterns that I wanted to cover they stung. It stung to read these. What the first one is called, I'll just say what all 3 of them are, and then we'll go into a little bit of detail. Covering your assets anti-pattern, Groundhog Day anti-pattern, and email-driven architecture anti-pattern. And I mean, I've got a half smirk on right now if you can't see me, but covering your assets anti-pattern. This one is procrastination. You're putting off a decision, and you put it off for too long, and then and a lot of it is because you're afraid of making the wrong choice. And gosh, this is a real issue, because you look at all of these requirements, you look at how the teams are supposed to work together, and especially when you're navigating uncertainty, you're like, there's like 3 different ways I could go about doing this, and I'm not sure which one it is. They give a good mediation, like a way to mitigate this, and that is to iterate, evolve, and work closely with the engineers. And I will tell you, this is the best advice, which is make the least worst decision that you can and just iterate and be very clear with everybody. Say, hey, look, with the constraints, I think this is how I'll talk about crawl, walk, run a lot. And so I would say, with the constraints, I think this is the best thing. We might have to correct course. So just let you know that, like, if we have to change this, make sure to build your software so that, like, we might have to swap this part out. Yeah. Have you run into this where you've maybe not gotten good specifications for something you're trying to build? Or I don't know if this resonated with you.
It did. I don't have any specific examples off the top of my head, but I started a job once, I remember, where I was really intimidated. I'd kind of, I was really excited to be at the company, and I worked with a lot of really smart engineers, but I was terrified of not being able to measure up. And that fear led me to procrastination. And so it's not exactly this right here, but I had to tell myself, like, I wrote it down on a piece of paper and taped it to my monitor. And I said, breaking something is better than doing nothing. And I really had to get it through my head that, like you said, you got to iterate, you got to evolve. But if you put off making a decision for too long, like, I don't know, again, you're covering your assets, like they said. So I don't have any specific examples off the top of my head, but I've been there where, yeah, you put off making that decision, maybe out of fear of the repercussions.
Yeah. And it'll bite you. And so one to me is, be honest about what you're not sure about early on, and then you can partner with your other stakeholders, right?
I found as I've gotten more senior in my career that it's very powerful to say, I don't know, which is like,
yes,
it's like the opposite, because you'd think as you become more senior, you should be saying that less. As I become more confident, like, I don't know. I think there's a lot of power. And even, like, I was in a meeting yesterday where everyone was using an acronym. Like, they were all talking about it. Like, I should know what it means, but I didn't know what it meant. And it was just really powerful to, like, stop the meeting and be like, that term you're using right there, I don't know what that is. Can you explain that real quick? And then I was shocked that, like, half the table nodded and they were like, yeah, I don't know what we're talking about either. So
absolutely,
as you get more senior, I think that's a way you can lead.
The other thing, so the next one, Groundhog Day anti-pattern. My gosh. So happens when people don't know why a decision is made. And so it keeps being discussed over and over again. And again, this is a form of hand wringing. Again, this is typically people are nervous, people don't quite understand. And so after you make a decision, the architect fails to provide a justification for the decision. So it isn't that somebody has heard something, it's probably that you haven't been convincing enough or authoritative enough, or you maybe didn't have a lot of times we'll have to have like a sponsor, like an executive sponsor or a leadership sponsor to make sure that this is done. The big thing here, and you have a whole section on it, is that any decision you make has to drive based on business value. And again, I've done this in the past where it's a wanderlust and I'm like, oh no, there's this cool new technology. And you're like, do you really need this? And they talk about this in the book where like one engineer wanted to move to Scala off of some other language. And he was just like, oh no, this is going to fix this. And this is way better language. And the architect pushed him and said, give me a business value for this. And he came back and he was like, I love Scala, but I actually am afraid. I think that this is actually going to cause risks to the project. And he became the biggest champion for doubling down on the way that they were originally planning to do stuff. And it was this way of like saying, hey, look, if you can give a business value, maybe the architect can amend their own methodology. But if they can't do it, push it off. And this way, the guy doesn't just do a hot take where he's like, oh, if we were doing this in Scala,
and that particular example they shared because it's also a way of not just dictating from on high and saying, listen, I've said we're not using Scala. We're not using Scala. Instead, you say, hey, if you can prove it, let's do it. And they say it's a win-win because either one, the engineer comes around to your way of thinking by way of experimentation, or two, they discover a really powerful business case for why you should use Scala or their particular pet technology. And now you've learned something new as a team, and maybe you can go a new direction. I thought that they talk a bit more about that. But some of these social tools are fun.
Exactly. And then, of course, the last one is email-driven architecture. And gosh, I will extend this to also include Slack, which is, so basically when people will lose, forget, or they don't know how a decision was made. And it was probably because this decision was made over email or Slack or informally in a meeting without meeting notes or authoritative things. There's also no clear ask for stakeholders. So you might say something is being done, but then you don't, and then there's also no timelines. So these are all the criteria for email driven. And so again, how to mediate this. All documents and decisions live in a permanent wiki or file store. You provide a clear ask with a deadline from stakeholders and use a confident voice in your communications. So instead of saying, I think we're going to go with Postgres, we go, it was decided that we're going to go with Postgres. This is how it's going to affect your service. I need you to give me feedback on whether this is acceptable in the timeline that we have. Here's the timeline, right? It's much more assertive. You're not being mean. You're not bullying people, but everyone's being pulled 20 different directions, right? If you don't give them some deadline and some like, hey, this is the decision that we're made, people will just sit on it and be like, did we make a decision? Like, I don't remember that. Or it's the day before something has to ship and they're like, well, we didn't know that the Postgres thing was expected of us, and you're like, ooh, it actually was.
Tanya Riley, in her book, The Staff Engineer's Path, which I believe is on our backlog, it's a great book, talks about one way you can be authoritative when communicating is avoiding passive voice. And she says a great way to understand if you're using passive voice is if you can follow up the sentence with by zombies. So if you say, it was decided we will use this, or, it was decided by zombies that we will use this, you're using passive voice. Instead, you say, we have decided. And, we just started doing this at my company. I was tasked with evaluating our build system. We were using GitHub Actions, but there was debate over whether or not, from a company perspective, we needed to be moving to BuildKite. And so I did a lot of research into it and understanding the pros and cons of each and kind of the larger landscape politically at the company of how GitHub Actions was. And I came back and said, listen, I think we can keep using GitHub Actions. I prefer GitHub Actions. And then I think there's a lot of reasons why we should. So I say we stay with GitHub Actions. I discussed it with the other senior engineers on my team, and they said, yeah, we agree. What I said, I'm like, okay, so we've made this decision. how do we make sure that we don't talk about this again? And so we started doing a decision log in the repo, and they talk about how there's benefits, and I would agree of doing it like in a wiki instead. But we have this decision log where every time a decision is made about the project, we just document it there and say, and we link back to the Slack conversations or the emails or whatever in That's that smart. And say, okay, we're doing GitHub Actions. We've talked about it. It's done. And I like the idea that if someone tries to say, hey, what about Buildkite? I'll say, you know what? We've had this discussion before. You can see this commit right here where we decided on it, and we're sticking with GitHub Actions.
Yeah, that's so valuable. So to tie into the next ones, and I know that to be sensitive to time and everything else, I think I want to give a nod to some of these, and maybe if you feel inspired to chime in on additional pieces, sections that I thought were really interesting. Analyzing risk, this whole section, I'm not going to get too much into the details. Analyzing risk has always been one that's challenging because you really start dealing with the unknown unknowns. And we've talked about this elsewhere, but they give some really wonderful frameworks for how to analyze risks, ways that you can make these little rubrics to make sure that you have consensus. And a lot of times analyzing risks is also talking to your team and saying, hey, what do you think the risks are here? And then, if somebody puts a really high risk score on something that no one else did, let them talk about it. Let them figure out, are they tinfoil hat paranoid thinking, or have we just not had experience with this technology and we're thinking it's simpler than it is, right? I loved that section.
And they talk about analyzing risk from like an architecture characteristic point of view, where you can say, okay, today we are talking about latency, right? Let's review the architecture diagram, and everyone again, they have like a scoring system, which we're not going to get into. Again, read the book. It's a great book. But you can kind of like break out the system into its individual pieces, and you can basically have each person give their risk score based on, it's a matrix of how big a problem do you think this is and how likely do you think it is to occur. And then you can kind of tag each individual component with the problems you might see come up, and then, you review it all together as a team. But I agree that it's just, there's a lot of formalizing informal processes that I liked from that risk analysis, right? A lot of times a risk analysis is just done by like chatting at the end of stand-up or during, right, a socializing hour or a lunch or whatever, right? This is a great way to get everyone in a room and say, let's all look at it together, and let's systematically talk about our risk areas in this architecture we've built. I thought it was a really neat concept.
Yeah, and this ties really well into how to make a team's effective. Like they talk a lot about, one of the things I loved is that they were like, the architect should go sit with the engineering team, right? The architect should spend lots of time discussing things with them, thinking about stuff. And I think one of the areas they talk about is like, you can oscillate between control freak versus armchair, or you can be just the right amount of architecture involvement. And I loved this one because it wasn't like, here's what you are if you're a control freak, or here's what you are if you're armchair, which is like very hands-off architect. It really depends on the seniority of the team, right? A bunch of junior devs are going to have to be treated differently than if you have a bunch of senior talent. How short or long the project is, right? So you actually can be, it seemed the opposite, but you can be more armchair in a short-term project, and you need to be more control freak in a long-term project, which sounds the opposite of what you think it would be. And mostly it's because you should be a blocker if you have a 2-year project and you need to make sure the architecture is perfect. Otherwise you'll have a big ball of mud because it compounds over time. Where you might need to be more hands-off to just let the team move fast over a 3-week or 6-week dev cycle. And
again, they give you that kind of framework to operate from, where they don't say control freak bad, armchair good, you or both bad, you must be right in the middle. They say, listen, you might want to be a control freak sometimes, because if your team is young and the project's going to take a long time and it's very complex, they're going to need a lot of guidance. But if it's a short project, you've got a senior team, short time frame, back off. They can handle it on their own. We're coming to the near Forgive me. I am jet lagged and have been at a conference all week, and I can tell that I can't even talk. We're coming to the end of the episode. I just want to give a quick shout out to, they have a whole section on negotiating and leadership skills. They have a section on presentation skills. I always like to say in this field with social skills, it's like in the land of the blind, the one-eyed man is king. We as engineers are very smart and very intelligent, and who are we kidding? We're not the most socially savvy people in the world. And so even a little bit of effort into patching up those social skills can really, it can be a big boost to your career. And they have, like, again, like, I don't know, I'm a fairly sociable guy. And so I was cracking up reading this part because it has things that's like, when you meet someone, shake their hand, give them a firm handshake, no longer than 2 to 3 seconds. Look them in the eye when they're talking to you. Make sure to use their name. I'm like, I was like, okay.
I've also definitely met those years that have been like, I'm like, you need this guide right now.
But like, absolutely. And like, I'm not knocking you if you need to learn it. Like, there's a lot of stuff that I read in this book, like about the different architectures, where I'm like, oh wow, I never considered that. It's totally possible someone could read all that stuff and be like, yeah, I got that. That, that's obvious. Of course you'd build a system that way. But then get to the section about handshakes, we're like, only 2 to 3 seconds. I was going like 10 seconds, It's a great section. And if you are someone who struggles with social skills, please read it, because it breaks it into some very concrete rules you can follow. And if you're someone who doesn't struggle with social skills, one, it can be a good affirmation that you're doing things correctly. But it's just, I think, and it's for me a great closing thought in the book. I love the holistic nature of this book. Yeah. It is not just about the different kind of architectures. It is not just about career stuff. It is not just about the philosophies behind architectures. It's everything. This is, I don't know how else to describe this book, but comprehensive. And it's comprehensive while at the same time feeling light and easy to read. It's a real feat of the authors. I loved this book. I honestly did.
It also shows that, this work is deeply creative. And I think that we don't give enough credit to the fact that, you think engineering and computer science, these like very, Boolean logic, mathematical things. But most of the ways that we affect change and the ways that we, build stuff is deeply creative. And this interpersonal skills is hard. And it's one I've struggled with in the past. There's, it's one thing to get credibility with your engineering team, but if you can't translate that to the marketing department or the product team or executive leadership, you're really going to struggle. And you may have incredible ideas, and if you can't communicate those, then you'll fail. And I know this just because of all of the failures I've had in various points where I look back and I go, wow, if I had a different strategy, or if I had really thought about the business value and these other things. So this is a cool thing. This gets in that last section, developing career paths. And I think this one is incredibly valuable, because being a software architect is an unconventional path, right? There is no clearly defined set of rules on it. And
you probably won't just wind up here.
No, not at all. I loved one of the first things they bring up is the 20-minute rule. And this actually is the nature of this podcast, right?
I had that exact thought.
Yeah. Like depending on, like, we both wanted to, I have a backlog of books, half the books on this shelf back here I've read, and the other half I've been, beating myself up over, like not reading them. You don't have to go and binge a bunch of books. What we've been doing here is, most days it's about 30 minutes, right? 30 minutes total that we're spending. And it's making this huge change where I'm getting through books. We're developing relationships. We're doing some really cool stuff. And it's the 20-minute rule is this idea that breadth is more important than depth, and that you should dedicate at least 20 minutes a day to your career. So how you do
learning new things, branching out. Yeah, I totally agree, because I think you could listen to this podcast and think that we're like weirdos. We're probably weirdos because we made a podcast about software engineering books, but we're like obsessive. But we mentioned in the podcast sometimes, but like Nathan and I are both dads. We're both married. We have hobbies. I run marathons. Nathan has another podcast, for crying out loud, right? This is not the only thing we do with our lives. And both of us have been shocked that, like, this isn't that hard. We do about 30 pages a day. It takes us about a 1 minute to read one page. And I mean, so far, like, as I've been at this conference for work, like, I've been really happy at how much, even in just the 6 weeks or so we've been doing this podcast, I feel like I've gained so much knowledge. I feel like I have so many more interesting things to talk about. I feel like I'm talking at a higher level just from 30 minutes a day. And they recommend 20 minutes a day. So look at us, we're 50% better than what they recommend. But that 20 to 30 minutes is all it takes.
Yeah, it really does add up. And this is one of those like it's like compounding interest, right? You do this thing that on any individual day seems kind of boring. Maybe some days you don't feel like doing it, but if you just do it, just spend that time, be mindful. And I think we've talked about this too. This is 20 minutes of like YouTube rabbit holes I'm not going down,
Yeah.
or wasting my time on Google News or something, like just doom scrolling or whatever.
I'm a shameless Twitter
reallocated that.
addict.
Yes,
And
exactly.
and same, it's like gosh, like why read like 500 tweets when instead I could spend, read 20 pages of a book.
Exactly.
Yeah, I think well, I was just gonna say, I think we like to talk about what we're going to do differently as in our careers as a result of having read this book. Nathan, what are you feeling?
Yeah, so when they closed out that last section, I think it was like really good. They said designers design, great designers design, of course. That's a Fred Brooks quote. To me, the last 2/3 of this book were a mix of like pragmatic and visionary leadership and methods. And so what I plan to do is continue to work on my negotiation and collaboration techniques. This really inspired me to make sure that I keep honing those. And so in my 20-minute rule, it's, maybe there's some non-technical books that can help me with persuasive leadership or, understanding how to collaborate on things better. I'm going to be adding more of that into my day for sure.
Yeah, I agree. I want to be better about more curiously exploring the different software architectures of the systems I interact with. I think I feel more confident after reading this book that, like, there's even I don't remember what book I read this in, but basically, when you have sort of that pattern recognition, like software built into your brain, it's easier to absorb and remember information. The example they gave was they would flash for like 5 seconds in front of in front of different people a chessboard, like chess, positions on a chessboard, and people who played chess competitively could remember just from that couple seconds of looking at it the positions far better than people who never played chess. Because if you've never played chess, it's just a collection of like chess pieces and you don't know what it means. Right. But if you've played chess before, you look at it and you say, that's this gambit or this strategy or this pattern, right? And so even if the whole board doesn't resemble that exact pattern you've seen, you might see the middle of the board and the 6 key pieces in that pattern. And then you can kind of fill in the details around it. That's how I feel after having read this book. Yeah. I don't know every software architecture there is, and I'm not an expert in any of them. I've seen the patterns now. And so I think when I come to a new system, I want to be better at being like, yeah, this is event driven. And what are we doing? It's a broker topology. Okay, great. And I think it's going to enable me to be a little more curious and to accelerate that learning. I just want to be more curious about it. And then we always like to say who would recommend the book to. Who are you feeling, Nathan?
Yeah, my recommendations are unchanged from last week, so I'll be happy to bring this up, which is software engineers that are senior level or above who want a deeper understanding of architecture trade-offs in a system. I think this book, being senior level, gives you enough context to really understand and have some of the scar tissue be like, oh, I didn't know how to describe that. Also, DevOps folks. So just because this is my background, DevOps folks really need to understand the architecture to help with the orchestration piece and making sure that we understand how to measure the system properly and we're tooling things the correct way. They really need to have a better understanding of vocabulary and philosophy of the why. A lot of times DevOps is very much in the how. That's where they are in the hierarchy of like, use this logging tool or we're going to implement this thing. I think anyone who wants to flourish in their career in DevOps needs to understand the why. And the only way to understand the why is to understand the philosophy behind it. And so a book like this is incredibly valuable.
I agree. My recommendation was any current or aspiring architects. I really could not imagine a better book to read than this. And what we're really excited, and we are not a count your chickens before they hatch kind of guys, but stay tuned. We may have some fun surprises that have to deal with this book coming to the podcast. Well, thank you so much for tuning in. This has been Book Overflow. I'm Carter Morgan with Nathan Toops. You can find me on Twitter at Carter Morgan. You can find Book Overflow on Twitter at Book Overflow Pod. We are on YouTube. If you'd like to interact with us there, we tend to respond to comments pretty quickly. Nathan, you can find his monthly podcast, Functionally Imperative, on YouTube. And yeah, leave if you're on YouTube, like, subscribe. If you're on Spotify or any podcast player, leave a 5-star review. These things, they really do help us. They boost us in the algorithm. They get us in front of more eyes, and they enable, as our reach grows, we have some fun plans for what's to come. So if you want to see this podcast grow and evolve, do your part. Right now, leave us that 5-star review, like, subscribe, whatever it takes. We really do appreciate you tuning in. If you've made it this episode, then we know you are a true fan. And we are so happy to have you along for the ride. Thank you so much for tuning in, and you have a great rest of your day.
Yeah, thanks, everybody.